Here's a reaction that you've run before. Copper sulfate is the blue salt. We can model it. This is a particulate model. 1 copper, 1 sulfate. Here's the particulate model for sodium carbonate. 2 sodiums, 1, 2, 1 carbonate. The reaction, you know, is interesting. Get a nice color change and it turns all cloudy. The cloudiness indicates we have an insoluble product. After using the centrifuge, there's a pellet here of the insoluble product. There's a fairly clear layer here, which is a soluble product. You know from using your Lego models that what started as copper sulfate and sodium carbonate ends up as copper carbonate and sodium sulfate. Copper carbonate's this green salt here. Sodium sulfate is a colorless salt here, just white boring. So all of this that I've showed you, the actual mixing, the formation of the product, the idea that there are different solubilities, all of that can be represented with symbols. And that is the symbolic language of chemistry. If you learn how to read it and write it, it is a very powerful tool. I'm now writing in the symbolic language of chemistry. This is copper sulfate. That's written CuSO4. Copper ion, sulfate ion. To represent that it was dissolved in water, I use another symbol. It's from the Latin word for water. Latin word for water is aqua. So when you see AQ in the symbolic language of chemistry, that's aqueous, which means dissolved in water. I reacted that with sodium carbonate. Sodium carbonate, you can see on the label, you can see in the model, is Na2CO3. That was also dissolved in water, aqueous. I draw an arrow. There was a reaction that occurred when I mixed them. There are 2 products. The first one is sodium sulfate, Na2SO4. The second is CuCO3, copper carbonate, CuCO3. I need to think about how to label these with phase notations. Is it aqueous or not? The results show you that something is not dissolved. That something is the copper carbonate. You could know this from experience, or you could determine it from a solubility chart saying, what is copper carbonate? It's not soluble. The symbol that's used to show undissolved solid is S. So copper carbonate is a solid. It formed in the reaction. There it is. You can see it. Sodium sulfate, on the other hand, if you look at your solubility chart, sodium sulfate, sodium anything, is, yes, it's soluble. So this sodium sulfate remained aqueous, dissolved. This string of symbols is a chemical equation. It is immensely powerful. It describes what happened in the test tube. It allows you to predict, will there be a insoluble product? Will I see a solid? The symbolic language of chemistry helps you predict that. Here's a chance for you to try out the symbolic language of chemistry. I'll set it up for you. Then I suggest you try to write it out on a piece of paper. Here's copper chloride. Nice blue solution. There's a way to write that in symbols. Sodium sulfate, colorless solution. There's a way to write that in symbols. And you can predict using the symbolic language of chemistry what will the products be. So try to do all that before I show you the answer. Here are the symbols, the formulas for the reactants. You can see there are 2 chlorides for every copper, and both salts start dissolved, therefore aqueous. What do you get out of that? If you haven't predicted yet, pause the tape and try to figure out what do you get as products. One of the expected products is that the copper ion separates from the chlorides and then joins the sulfate. That's an expected product. I can write that as CuSO4. We'll think about what phase will that be. The other product will be the chloride ion combining with the sodium. That looks like this as a model. NaCl. NaCl. 2 products, copper sulfate, sodium chloride. We'll look at that as a phase notation. You should see, however, there's a problem that we started with 2 chlorides, 2 sodiums. I only have shown 1. There has to be another one produced. 2 copies of sodium chloride. Put a capital 2 in front, a big 2 in front. 2 sodium chlorides are produced in this reaction. To determine whether these are dissolved, solubility chart can help. Solubility chart can help. Copper sulfate is right here. Yes, it's soluble. Sodium chloride down here. Yes, it's soluble. If I run this reaction, my symbolic language tells me I should be expecting 2 aqueous products. I'll try it in real life. We'll see what it looks like. Here they are. The copper chloride is blue. The sodium sulfate is colorless. There they are. When I mix them together, I think you can see it's pretty boring. There's no obvious new substance formed. It's clear, transparent, which means the products are dissolved. The symbolic language helped me predict this would be the outcome. Both products are soluble, so no solid will be observed.